Hello, everybody, and welcome to today's webinar, Holistically View Your Operations with Machine Monitoring. So as you can see, we'll be looking at how Tulip upgrades your airproofing and process and improving traceability. So how we can use machine monitoring to really help you elevate your shop floor. So speakers today will be myself. I'm Giovanni Carrara, Community Manager here at Tulip, and we have Juan from App Engineering. Juan, do you want to quickly introduce yourself?
Yeah, sure. Thanks, Gio, and thanks everyone for joining today's webinar. I'm excited to talk about this topic. Machine monitoring is something that I spent a lot of time doing in Tulip. And so, yeah, as Gio mentioned, I'm part of our application engineering group and work a lot with our customers to get their machine data into Tulip. I have a lot of experience, working on the shop floor as a controls engineer, doing PLC programming, SCADA, all that. And yeah, happy to talk about this with you all today.
Thank you, Juan. First of all, let's understand what is machine monitoring. As we get started, this is kind of paints a picture of the way that a shop floor may look like today before Tulip. So there's a series of potential improvements within this image. So the first thing you'll see there, you'll see the team member inspecting a part manually. So, they're measuring the part using some hand tools, and this data, maybe they're collecting it within their head, but they're not really taking any actionable information with it. They're not recording it anywhere. It's kind of going lost. Moving down to the bottom left, you can see there's some dumb sensors. So sensors that are not connected to the internet, that its values are not being recorded, that are very useful, but they're not being recorded for traceability. Then we have a lot of the setup sheets and instruction manuals for the machines that are all paper-based, that can go out of sync, they can go out of date, and they're just hard to manage and hard to keep up to date. We have that. Then we have calculators that team members use to calculate whatever numbers need to be calculated with regards to the performance of the machine or the shop floor on a more holistic level. But there are calculations that are being done that are not really being used in an insightful way. The status of the machine is being tracked on paper or with an andon light or something, but it's not really visible unless you're right there at the machine. Then we have these complex HMIs with interfaces that were designed several decades ago, and they're, if you have a lot of experience with them and you're used to using them on a daily basis, it's okay, but otherwise they can be a little bit not so user-friendly to start with. And then finally, down at the bottom right, we have paper-based job tracking. So we have travelers or something similar moving around the shop floor that users are using to track the work orders, but can easily go lost. Hard to have visibility unless you're right there at the machine. It's hard to know exactly what's being worked on. So now let's take a look at how Tulip machine monitoring apps are different. So what you're looking at here is an app that could be running on a tablet at a machine. And as you can see, with Tulip, you can monitor the overall process, not just the machine. The beauty of it is that you can collect data in context. That's what we call it. And essentially it means marrying different sources of data. So it's not just the machine data that Juan will explain to us how we can track in Tulip, but you can actually marry it with lots of other inputs. So starting from the left, you can see and connect to a lot of protocols that, again, Juan will be going through in a couple of minutes, but you can connect to the machines and record what they're outputting into Tulip. But then this only gives us part of the picture, because on the other hand, we have people who are operating these machines who can give very insightful information that we can use to drive improvements. So for example, at the bottom, we have human input, reasons for downtime. So we often see, okay, the machine goes down. The machine may have a set of pre-built codes, but they're actually not that useful. What we really want to know is from the person who's operating the machine, why did it go down? And they can write some text or choose from drop-down, or you can build your apps any way you'd like to collect the information you need. Then moving up towards the right side here, in Tulip, you can also very easily integrate with your ERP, with your MES, or with any existing database to, again, marry the data that is coming in from the machines, coming in from the humans, and you can marry this with data that is coming in from any system that you have within your organization. And the beauty of this is that, a lot of these apps are made available to you through the Tulip library. They work out of the box without much configuration. But then with Tulip, you can essentially just move things around in a no code environment. So just with a drag and drop, same way if you'd be building a presentation or something like that, you can move around widgets, text elements, information on your process on your screen very easily. So one of these things that you can build is a dashboard for machine monitoring. So once you connect some machines to Tulip, you can see how you can very quickly build dashboards to get a detailed view. You can start from as low level as you want. So you can start from the individual machine, you can go up to an entire cell, an entire line, or an entire facility, or multiple facilities. So the screenshot that you're looking at there is actually a top-down view, 2D view. You're seeing real-time widgets of the status of the machine they're in. So the green ones mean they're running, they're cutting parts, they're making parts, whereas the red ones are down for some reason, which could be a good cue to go investigate. Let's go see what's happening, and let's make sure that the entire facility is working in harmony. You can also track performance over time, of course. So you can customize your dashboards to any time frame that you'd like. If you'd like to do a weekly analysis, monthly, yearly, whatever it is, you can kind of view the performance of the shop floor over time by, again, individual machine or by entire facility. Then down in the bottom screen, you're seeing a configuration for a dashboard. Again, up at the top, we're seeing a real-time view of what the machine is outputting, and then some analyses for the historical performance of the machine. And these can be configured very easily exactly to what you want. So if you want to display OEE, you can very easily input the calculation that you use for OEE, and then automatically it stays up to date. So you don't have to calculate it every day or every week. It's just every time that Tulip receives data from the machine, your OEE is updated without you having to run any calculations or anything like that. So just kind of giving a little bit more insight into what Tulip is. Tulip is the only platform purpose-built for frontline operations. So again, in the no-code environment, you can very easily set up terminals, you can set up multiple steps, nested pages, and tailor your apps, build your apps without writing a single line of code to help you do the processes that you need to keep your operation running. These are very multimedia-rich apps. You can embed videos, CAD files, images, PDFs, whatever it is, you can embed them within your Tulip apps. It's all done in a drag and drop interface, so there's no coding involved whatsoever. It's all just selecting from the drop-downs and designing the interface the way you like. The very cool thing is that you can define triggers to streamline complex applications. So we'll get into this in the demo later on, but you can essentially define, okay, when a user clicks a specific thing, or when a timer goes off, or when a machine outputs something, you can trigger certain events. So if you want to track, for example, whenever a machine outputs an alarm code, you can very easily do that and then send the supervisor a text, for example, or do something, a workflow like that can help you manage your shop floor. Tulip can be used without the connection to the machine, so only using inputs and outputs from humans, but you can also record and take action on machine outputs in Tulip. So again, using the same drag and drop interface and selection from dropdowns, you can define custom action in your apps based on machine outputs. So like I was mentioning, if you want to say, okay, every time a machine outputs an alarm code, let's send the supervisor a text message, you can very easily do that just by selecting a series of dropdowns. But then on the other side, once you connect two machines, Tulip also records all this information in the background without you having to do anything. So once the connection to the machine is set up and you define the various states of the machine and how they switch between the states, you can record machine data in Tulip seamlessly all in the background without Tulip having to be running on your shop floor. So we'll go take a look at that as well later on in the demo. But now that we kind of have an overview of what Tulip is and what machine monitoring in Tulip is, let's take a look at a couple of case studies. So we think it's important to monitor machines for a number of reasons, and these reasons can be mostly grouped into these three larger buckets. The first one is to improve asset utilization. So once you surface insight on the machines, when they're running, when they're not running, when they're not running, why are they not running, and doing root cause analysis, we're able to better say, okay, let's make an improvement, let's shift around some of the workloads, let's do some retraining on some of the teams, whatever it is. But surfacing this information is the first step to helping you improve asset utilization. The second bucket is to collect data from the process, thus improving traceability. A machine doesn't necessarily need to be a big machine like an injection molding machine or CNC machine. It can be actually a smaller machine as well. But once we connect to it, we can record all the information that it's outputting and that you can use to either create a digital twin or track information on a specific process. So if you need to record, for example, specific information for, as you can see there, weight of a batch record. You can easily do that and track that information without the user having to input anything on the tablet or without having to record anything. There's no room for error because the machine just outputs what it's recording, and it's a very good way to kind of get better traceability of your process. The last bucket that we see, but it's also a very important one, is to guide operators and error-proof processes. So if you remember earlier from the picture from the shop floor, what it looks like today, there's paper flying around everywhere that can easily not be used by users or is not so relevant or gets out of date. Whereas with Tulip, you can build a very simple app, display the information to the team member who's operating the machine so that they know exactly what to do. So in the image there, you're looking at a guided assembly flow in which there's many combinations that can be followed, and the team member there is being presented with specific assembly guidelines for what to do in what specific order. So this is a very simple pick-to-light system, but that can be very effective to help poke the system and eliminate errors in assembly. So looking at a specific couple of examples, the first one here, this is a customer who set up cycle sheets and real-time scrap monitoring and management solution with Tulip. The problem was that scrap is a main KPI to impact, but it was very hard before Tulip to quantify the scrap and to get data on the scrap to make impact at the right place. So like I was mentioning earlier, because it was paper-based, people were sometimes tracking, sometimes not tracking scrap. Some of the paper was getting lost, some of it was getting recorded. It was time-consuming. It was not process-driven, so it was different continuously. And it was just hard to see what was driving a lot of the scrap. So with Tulip, they connected to a bunch of machines, 90 machines, and the machines were outputting a lot of information that this customer used to actually track, okay, every time we were scrapping something, the customer would track, why are we scrapping this specific thing? How many did we have to throw away? What was the root cause? And it would really help drive improvements, because at that point, once information is surfaced of when we know why things are being scrapped, we can far more easily drive improvements. And you can see there, the results speak for themselves, but drastic reduction in scrap rate and a 60% increase in time savings per cycle sheet. And as you can see here, another thing that I think is very important to note is that the timeline is very quick. Whether your machine is already connected to an OPC UA server, it's a very quick process to kind of start streaming data into Tulip, build your triggers, and start using them in your apps. Just a matter of a couple of hours to get everything set up. But then another interesting case study is another customer, Taza Chocolate, facing growing production demands, but they had a lot of analog machines, so machines that they're not connected to the internet, they're not smart machines. And so it made it difficult to track key production information during these runs to drive improvement. So the solution was to attach a bunch of sensors, sharing some information on the types of sensors that we can connect to. So it doesn't need to be brand new machines. We can connect to older machines as well. And using Tulip, Taza was able to track performance data in real time and optimize their production processes. And simply by being able to track this information and understanding where to drive improvements, they were able to experience 30% increase in chocolate production while decreasing cost of goods sold. So interesting example of how some older machines, still very valid, still very valuable, can be brought into the modern world. So now I'm just going to briefly talk about the Tulip library, a couple apps, and then I'll hand it over to Juan. But for those of you who don't know, the Tulip library is a configurable best practices apps, app suites, and connectors for frontline operations, all free of charge. So you can navigate, you can browse by use case, by industry, you can search for a specific app, and you can download a pre-built app into your instance that the Tulip team built and is made available for you. So once you install it, you can use it right out of the box, or you can configure it to meet your needs. So these apps exist for many different use cases, but they also exist for machine monitoring. So the first one I want to share is the machine monitoring dashboard. The machine monitoring dashboard is an app in the library that allows you to monitor machines, track status, and visualize performance across your facilities in real time. So we'll be showing some of these analyses that you can build later on, but first of all, you get the full picture. So you can have the context in the facility map, like we were showing earlier, top-down view of the facility in the map and understanding which machine is running in real time and which is not. You have real-time metrics to quickly view whether a machine is online, down, from anywhere in the world. So you don't have to be on the facility, you can be on the other side of the world and understand how facility that you have is running, and it allows for configuration. So you can very easily configure the dashboard app to fit the process specific to your operations. And the other app, and this is actually not an individual app, it's an app suite that we wanted to share, is the Machine Shop app suite. So this is an end-to-end solution for your shop floor. These are just some of the highlighted apps, but you can track your machine changeover. So machines sometimes can have quite a complex changeover procedure that can be hard to follow. You can build a series of apps that allow the operator to kind of go through step by step and make sure that the changeover is done correctly. You can have part configuration to allow for different setups depending on the part to be set up correctly to fit your needs. And there's a request fulfillment app that allows you to kind of mark jobs completed, materials ready for delivery, for pickup, for whether you're running short on some supplies. You can manage your inventory using an app in this suite. But now with that, I wanted to hand it over to Juan, who will be going over some of the protocols and ways to connect machines to Tulip.
Thank you, Gio. So yeah, kind of what I'm going to talk about is what does it look like for Tulip to connect to your machines on the shop floor. So I'm going to start by outlining what are some two common approaches that I work with our customers to get their machine data into Tulip. The first is, probably the most preferred, the most straightforward way is that Tulip connects to an OPC UA server that resides on your network. That could be something you use for your SCADA system or process historian, et cetera, right? So Tulip will make an inbound connection to that, and then get the map tags that reside in the OPC UA server into Tulip, so then you can use them in your applications. The other approach that we have is we leverage an edge device that's running Node-RED, and I'll kind of talk about more about what Node-RED is in a little bit. But basically, we're going to use the edge device with Node-RED to leverage a service that we provide, the Tulip Machine API, to get machine data into Tulip. The Node-RED approach is preferred because you can get your data into Tulip without having to write much custom code. The approach that you'd use Node-RED for is if the machine, for example, doesn't know how to speak OPC UA, right? It's a legacy machine, right? It kind of predates these protocols. The edge device would be paired with the machine in order to get data associated with that machine into Tulip, right? Again, without having to write much code. So it doesn't matter if your machine's legacy, it's from the 80s, predates OPC UA or DA, or it's a more modern machine that knows how to speak OPC UA. We can effectively monitor these machines in Tulip, again, without having to write much code. So kind of talk more about architecture, right? So I think it's important to note that Tulip supports OPC UA natively. So as long as Tulip can connect to your OPC UA server, there's nothing special you need to install or configure. You just need to specify the endpoint that your OPC UA server has on your network. The service that connects to your OPC UA server is called the Tulip Cloud Connector Host. Basically, it's going to act as an OPC UA server or OPC UA client that connects to the server, again, to get the map tags that you have in your server into your Tulip application. And so from an architecture perspective, we whitelist Tulip at the outskirts of your network to securely connect to your OPC UA server. What this means is you could have an OPC UA server running in a DMZ environment, and the OPC UA server is connecting to your machines on the shop floor. So in this instance, Tulip's only connecting to your OPC UA server. It's not connecting to each individual machine that you have on the shop floor. I think it's important to note, following best practices. So assuming that we've successfully connected to the OPC UA server, what does the machine data look like in Tulip, right? So what you're looking at on this page is the machine configuration page. And what I want to do is kind of talk about what some of these fields mean. If you look under the machine details section over on the left, we're defining a few things here, and I just want to talk about what these mean, right? So machine name, straightforward. You can name the machine whatever you want. A machine data source, that is basically the endpoint of your OPC UA server, right? We're telling the machine that we're going to grab data from this OPC UA server. Station, you can assign the machine to a particular station, but we're not doing it in this instance. And then machine type. So kind of talk about more about what a machine type is. So a machine is basically a way that you can organize your data, right? The machine type is a way to standardize how you define that machine, right? So to kind of think of it from an object-oriented perspective for those that have experience with this. Basically, you're defining a class, right? You're defining some data within that class, and then you're instantiating objects of that. That's a similar approach where we define a machine type, and then we create machines of that machine type. And what this does is makes it easier to quickly deploy and scale as opposed to doing the steps for every machine that you want to create. So you define the type, you have a good baseline you want to start with, and then you add machines of that type as you start monitoring more machines in Tulip. Again, each machine has attributes that we call them in Tulip, and these attributes are going to be mapped to tags that are in your OPC UA server. And that's what you see under the field mapping. Since we have OPC UA data coming in, you can see it in real time just to make sure that it's what you're expecting. You can map it into a machine attribute. And I think it's important to note that sometimes OPC UA tags, the tag structure that you have, might not be consistent, but mapping them to machine attributes in Tulip can standardize the way that you're going to present data in your Tulip application. So that's kind of it for OPC UA. But now I'm going to transition more to analog machine monitoring or legacy machine monitoring. I just want to quickly touch base on what is Node-RED, just so everybody's on the same page. So Node-RED is this low-code, flow-based programming framework or tool that was originally developed by IBM, but now it's open source, part of the JS Foundation project. Basically, it allows an easy way for you to connect your hardware, sensors, and your cloud services like Tulip together to do machine monitoring without having to write much code. And what you're looking at on the screen is an example of a flow where they were measuring some temperature and then we're processing it and then sending that data into Tulip. Again, there's no code here. There's just nodes. You connect them together, and each node performs a specific function, and you can connect to Tulip. So again, it's originally developed by IBM. It's open source now, so Node-RED is a growing community. There's always nodes being developed that you can leverage, and it's built on top of Node.js. And I think this is an important point to note because when I suggest Node-RED to customers, they say, "Oh, I've heard of Node-RED for my home automation products, but it's just good for industrial real-time data applications." And Node.js as a programming language is good for real-time data ingestion. So to have a framework that's built on top of that, you can be rest assured that Node-RED is good for your industrial application. And another point I want to make is it's easy to integrate into the IoT protocols such as MQTT. You also can there's Node-RED nodes for like BACnet, for example, right? Again, there's a growing number of nodes out there, and you can I invite you to do your own exploration to see something that best fit your needs based on your lay of the land. So yeah, so just to kind of define what is an analog machine, basically we define machines that don't know how to speak these modern protocols such as OPC UA. And so again, for these analog machines, we're leveraging an edge device, a separate piece of hardware, such as the Tulip Edge MC, that can measure this data associated with meat and then send that data to Tulip, ideally through a low-code platform such as Node-RED. So what are some sensors that we use for machine monitoring that could be tied to this edge device? You could use RMS current, right? You could have a current clamp that's measuring, for example, current for a machine. Then from that, you can derive power, right? You want to calculate power consumption, vibration, temperature, pressure flow, photo eyes, etc. It's kind of up to you, kind of what sensors tie for the edge device that you can actually derive value from your machine monitoring. So from an architecture perspective, this is what's going to look like. Is you have an analog machine, right? There's some data associated with that. Maybe the analog machine's outputting that data. We have some peripheral devices that are helping you do the machine monitoring of this. That's going to an edge device, dealing with Node-RED. That Node-RED flow send that data up to the cloud, and it's hitting our Tulip machine API to get your data into Tulip. When you're doing this analog machine data in Tulip, it kind of has a similar look and feel. I just kind of want to point out some differences that we have. So we define the machine name here. Data source, you notice before with OPC UA, we were specifying an OPC UA endpoint. This we're just saying we're leveraging the Tulip API. Another point is here that the machine data is coming in through this attribute and machine. So if you look in the field mappings under Tulip API, so the attribute and machine ID, that's what you're actually going to use in your Node-RED flow, so you know the address in which the data is going to be sent into Tulip. And you can see, you can test it out, make sure that the data that you're getting is what you expected. So yeah, that concludes it for me. I'm going to pass it over to Gio now, and we're going to go over a live demo just to get you all started with machine monitoring in Tulip. Thank you.
Thank you very much, Juan. So as you can see here, basically what we're looking at is a Tulip player. So the Tulip player is what you use to run your apps. So this is done on a tablet at the machine, but it doesn't necessarily need to be at the machine. It can be, like I was mentioning earlier, the other side of the world. It doesn't really matter, but anyways, the Tulip player is running, and here what we're looking at is a dashboard. This is what is called a control tower view. So essentially on the right, and this is all built by a user with, again, a simple drag and drop interface. But we're looking at a top-down view of a facility. So actually, starting from the top, the first thing that we see is OEE. So you can see the three elements of OEE being calculated individually, so quality, availability, and performance. And these are up to date. In this specific case, it's for this week, but you can customize them to anything you need. And all the way to the left, the overall OEE for the whole facility. So again, this doesn't need to be done on a regular basis or on a recurring basis. Once you connect your machines to Tulip, with either of the methods that Juan was discussing, this information stays up to date seamlessly, and you can check in whenever you want and go check the OEE. Then on the left side of the screen here, we have basically a dashboard, a couple of dashboards that you can build very easily. These are called analyses within the Tulip platform that show key performance information. So the top one is showing how much of the time the machine was stopped, so split up by individual machine, how much it was running, and how much of it was idle. So these can be configured to any way you'd like. Whereas on the bottom here, we have a series of downtime reasons. So these can either be downtime reasons that are output by the machine, that whenever an alarm code goes off, you track that as a downtime reason, or they can be tracked by the operator at the machine. So you can say, okay, for example, you can see here, the main cause of downtime at 83 hours for this week was maintenance. So this can really help you determine where to drive improvements within the facility. And you can see the whole Pareto chart for all the downtime reasons. Then over here on the right side of the screen, we have the top-down view of the facility, showing all the machines, and you actually can see the red and green boxes there. They're actually displaying real-time information on the specific machine. So whether they're running and they're green, or you can see some of them just switched status. They went to idle, they went to stop, sorry, they went to orange, and now they're switching back and forth. Just, but you can have a very good high-level overview like this of your facility. But then once you click into the specific, click into a line there, you can see for this line, you can see all the machines that are running, their status, how long they've been in the status for. So for example, this machine here at the top left has been in stop status for 3 minutes and 2 seconds. You can see all the tags that Juan was describing. They're outputting what they're outputting in this current moment. You can see all of this information. And again, these are just very simple drag and drop widgets that you can customize. You can change the look and feel, you can change the colors, you can change the information they're displaying. You can configure them exactly to match your process as it's happening on your shop floor. Then you can go in and build analyses, historical analyses on the machine. So for example, we can take a look at, okay, let's take a look at the machine state by type on an hourly basis. So say we have 4 machine types, doesn't matter whether they're a lathe, a mill, injection molding machine, a press, a robot, whatever it is, you can group them by type, and then you can view their performance on an hourly basis. That's just kind of rolling, and you don't need to run a new report, you don't need to do anything, just stays up to date automatically once the machines are connected to Tulip. Of course, you can do the same. You can extend this to a weekly basis or also a monthly basis. You can easily filter these analyses to whatever you would like. Now I'm going to go in and share a little bit how you can actually build these apps, connect to the machines, and what that looks like from Tulip. So what we're looking at here, when you connect a machine, all these dashboards work out of the box. So you don't have to do anything. You connect to your OPC UA server or any other way that you're connecting to it, and you get these timeline views of the machine. So they're pre-built for you. You get a timeline, and you get these widgets that are pre-built, displaying what they're outputting. So here within our machine library, we can see a couple of the machines that I have connected. In my instance, these are mock machines. But you can see the machine name, you can see the machine type, the data source, so where the information is coming in from, and optionally what station they're assigned to. So now, once I open up a machine, we can see, first of all, we get an activity table showing all the states that it's been in over time as it's switched, and this will be very useful when we want to build the analyses that we were showing earlier. It will be driven off of this activity table here. And this is what Juan was describing earlier with regards to the field mappings between the OPC UA server, the fields in the server, and the machine attributes. So essentially, you can link them up any way you'd like. That you can then will then show you how you can configure these in the machine type. So now, if I go back into the machines over here, navigate to machine types, and open up this specific machine type. So, like I was mentioning earlier, it doesn't matter if it's a CNC mill, CNC lathe, injection molded, whatever it is. You can define types for the machines, and you can define the state, downtime reasons, and the machine attributes for this machine type. So in this case, this machine is a CMX 650, and we can see that I configured the state to be defined by some attributes that the machine is outputting. So whenever the machine outputs status and it's equal to true, so basically the machine has a tag that is status that it outputs when it's running, then I'll go in and I'll create the machine state to running. So this is custom defined by me, because that's what, the machine, when it outputs the status tag as true, it means that it's running. So it's a very simple thing. Sometimes people use, if you want to use, for example, you want to come in here and you can say, okay, when the machine attribute, you can look, okay, you only want to consider it running if the spindle speed is above X. You can very easily do that and configure from these drop downs how you would like to derive your machine state. So yeah, this is again the activity field for the entire machine type. That you have all your machines mapped out in here, and we won't go into the details, but you can customize similar to what we were seeing earlier, all the downtime reasons and the specific attributes. But the other thing that I wanted to show is a little bit what this looks like from the app builder side. So once you've connected a machine to Tulip, whether it's through OPC UA or analog machine monitoring, you can use the outputs in your apps. So here, you can come in here and you can see all these are just widgets that this one here is a machine timeline widget. This one here is a machine status widget that is mapped out to the machines that I have available. So, you can just come in here, you can embed machine status, machine attribute, machine timeline, whatever it is. You can configure your, and actually I can show you here what this looks like from the facility map that we were looking at earlier. Yeah, you can see here, basically you can overlay an image of your facility, and then on top of that, you can put in analyses, you can put in machine widgets that display what's happening to, what state the machines are in. And again, it's very simple. It's just a matter of dragging in the widget and displaying the status that it's in. The last thing that I wanted to show here from the app builder side that I think is a very powerful feature in Tulip is sharing basically how you can run triggers. So this is what we were saying earlier, the trigger portion, where you can define custom actions to happen on a button click or on a timer or whatever it is. You can also define them on a machine. So we can say, okay, when a machine outputs a specific tag. So if, say, for example, I want to send an alarm to the supervisor when an alarm is output, we can easily come in here. We can say, okay, if the machine output alarm contains, for example, I don't know, static value error, because I know that that's an alarm code that means the machine is no longer running, then I can come in here and add a new action, and I can send an email, I can send an SMS, and send it with an image. I'll choose send SMS. I'll send it to user. I can choose from the list of users. I'll choose to send it to myself. And I can decide what to send as a message. So I can send the actual alarm code. So now essentially with this simple trigger that we built using just a series of drag and drops, every time that this specific machine, so the 001 outputs alarm, if the alarm code contains error, then I'll receive a text message with this error code. And of course, this is very useful, if you need a very quick and easy way to communicate between the supervisors and technicians on the shop floor and kind of manage your processes. This is a very quick and powerful way to build these triggers. But so with that, we have about 15 minutes left for questions and answers. We can get started with the first one here. And Juan, do you want to take this one?
Yeah,
Yeah,
so reading it now. So the question is, does this monitoring only work with sensor input data? Can the data be entered in manually? Yes, you could create an application that kind of combines the sensor input data that you have, and then you can have some manual entry of data to then provide context to that. So that is possible in the Tulip platform.
yeah, that's exactly right. So yeah, you can, you can have inputs, whether they come from kind of text fields or single selects. It's easy to, again, marry the data between machines and the humans in that way. So then there was another question regarding types of machines, and it looks like there was a question about connecting to a carding machine and a loom.
I guess theoretically it's possible, but I would have to, I guess, know more about some of the protocols that the machine outputs, or just the feasibility of maybe connecting an edge device to that. I'm sure it's possible though.
Yeah, it's exactly right. So there's lots of, for example, in the second case study that we were sharing earlier, there's lots of examples of machines, very old machines that have been around for a while that were, that are not connected to an OPC UA server that we can connect to with, kind of any off-the-shelf sensor that has a digital or analog output that we can connect to. You can start streaming data in. Another couple of questions. Where is the data stored so that the monitoring app can utilize it? In Tulip tables. So it was actually in that activity field table that I was showing earlier. It is very similar to a Tulip table. That's where it's stored in by default, but you can also configure it to store it in a Tulip table if you want. So instead of, in that example I was sharing where I was sending a text message, you can also have it create a new record in a Tulip table. Or you can also send the information to your ERP or to wherever you need, to a database that you have external to it. You can configure basically to write the data that is coming in from the machine into those external systems. You can configure that to fit your needs, but by default, it stores it in the activity field. Looks like there's another question.
Yeah. So the question is, how is time synchronization managed between machines hooked up to the OPC UA server versus the Node-RED/analog/edge setup? And so when Tulip connects an OPC UA server, it's acting as an OPC UA client. So it's going to leverage any like timestamps or time synchronization that's in the server. When you go to the Node-RED approach, you're hitting our API. So you'd have to kind of manage like timestamp and all of that in the Node-RED platform. So for example, if your Tulip platform's set to run at Pacific time, you'd have to make sure that your timestamps in Node-RED are set for Pacific time as well. That's not going to happen automatically. So in your flow, you just have to specify which time zone and make sure it matches in Tulip to what's happening in Node-RED.
Okay, cool. And then there was a question about data security. Juan quickly went over that in section. I think it can get, we can definitely provide more information. I don't think, or unless Juan, unless you want to address some of these questions quickly on a high level, but.
Sure. Yeah, I'll address this at a high level, and I could definitely share more technical details with you if you're interested in that. But Tulip is a multi-cloud platform, so we definitely follow best practices of AWS and all that. The question is, can you talk about data security? How is data in the Tulip cloud server protected? Is there a way for some data collected to be kept internally to my company and not on a public Tulip server? Yeah, I'll definitely send you more information about that, but that is theoretically possible.
Great. So it looks like those were most of the questions that we got, but we have a whole series of webinars that are coming up. You can go to tulip.co/webinars to stay up to date on the upcoming ones. But with that, I'd like to thank everybody very much for joining. It was great to see folks from all over the world. So again, thank you for joining. Thanks, Juan, for walking us through some of the details, and we look forward to seeing you on the next webinar.
Thank you, everybody.